So can you tell us a little bit more about this graded motor imagery that you mentioned? How does it work, and how do you think it will work for spinal cord injury related pain?
Yeah, so it's a pretty exciting therapy. Graded motor imagery is a therapy in and of itself. It's a protocol of 3 different tasks. And the overall purpose of graded motor imagery is that it uses the movement related parts of our brain to address pain. And so it works even if somebody has lost the ability to move, which is why we think it could be useful for people that have had a spinal cord injury. In short, we are trying to access the brain's amazing power of neuroplasticity, which is its ability to adapt and change. We're attempting to kind of reorganize the neural networks that are responsible for movement. And then we see that it can actually reduce pain. We see that it reduces pain in other populations or other conditions. So, for example, with phantom limb pain following amputation, or in complex regional pain syndrome or post-stroke pain. But it has never been adapted to be useful for someone that's had a spinal cord injury. And so that's what I'm very excited about my PhD, and very thankful for the Hopkins Centre for the grant to do this, because I think there's a lot of potential in adapting this graded motor imagery therapy to be useful for someone that's had a spinal cord injury. Now, at this stage, I will tell you the 3 different phases of this therapy are left and right judgments. So someone's ability to say whether or not a hand or a foot is the left or right side of the body. The second phase is imagined movements. So simply imagining yourself performing movements. The third stage is mirror therapy, which some people might be familiar with, where you place a mirror in between your two limbs, and you have the non-painful limb reflecting in the mirror, and the reflection of that is in place of the painful limb. Now, we can't do that with spinal cord injury, because if someone's had a spinal cord injury, it's most likely that both limbs are affected, both hands or both legs. So we can't just stick a mirror in between them and ask for movement or for function. And so where this new kind of stuff that's never been done before in my research it comes into play is we're using virtual reality to have people go into a virtual environment and assume an avatar or the character in the virtual reality environment. By them assuming a first-person view of their avatar and getting them to look down to see 2 walking legs, we are wondering if that experience in the brain, or how the brain perceives that experience, has a similar effect to mirror therapy in the original graded motor imagery protocol. So currently my PhD is investigating whether having a spinal cord injury impacts those 3 different tasks. So the left and right judgments, the imagined movements, and how it feels to do simulated walking in a virtual reality environment.
Sure.
At the end of this, the information that I get with seeing how having a spinal cord injury impacts on these tasks, I'm then going to put together a protocol for an upcoming pilot clinical trial to actually see if we take somebody that has spinal cord injury related neuropathic pain and we take them through a structured program of these 3 tasks, does that impact on their pain? And it would be so cool if it did. But stay tuned. So that's what we're currently working on.
Absolutely fascinating. So I guess watch this space for more information and as the work is completed.
Definitely.
Yeah, thank you. Thanks for all your time today, Kim, and we definitely look forward to hearing more from you as the PhD kind of runs its course. And yeah, thank you so much.
Well, thank you so much for this opportunity. It's been awesome.
Great to have you.